Okay, so welcome. I've been requested many times to do a really brief video on sort of my workflow, how I do things, and more to the point, how I render things. So this video is about that. This is the first time I've done one of these videos. It's going to be fairly free-flowing, so apologies if it's a bit rambly. Okay, so I actually have something pre-prepared here. So if I just go to the end, and you'll see this is the iPhone 10 model that I've got uploaded sort of all over the place. And this was designed from the information that Apple provide to accessory designers. So it's pretty accurate. It's about as accurate as you're going to get without having an iPhone 10. And when I designed it, I didn't have an iPhone 10. I do now, thankfully, and yeah, it looks pretty damn similar. So that's really cool. So anyway, so back to the beginning, and you start off with nothing, and we're just going to step through, and you can sort of see sort of the different processes and how I did things. So first step, as always with everything Fusion 360, is you want to create a sketch, and the sketch is the correct dimensions for the iPhone 10 without any sort of fancy radii or anything like that. And as you can see, they're not the most round numbers in the world. I'm fairly sure this is due to a metric to imperial conversion, or Apple just like very, very unrounded numbers. I don't know which. I'm going to give them the benefit of the doubt and think it was rounding error. So all I did was I created a rectangle, which is the center rectangle here. Literally just click there and dimension it up. Boom. And that's it. So first point, I always pretty much start with the most basic primitive that you can have, just because it makes life a hell of a lot easier sort of down the line. The trick with it is to have a very basic primitive to begin with, and then after that you can then have additional features, and it's just much easier to control what's going on. Okay, so we'll stop that sketch. There we are, we have a sketch now. What's the next thing to do to it? We want to give it some thickness. And for that we're going to use the Extrude Modifier. And what would usually happen when you do the Extrude is the sketch would disappear. And I'm just tumbling around here by using the Shift and middle button. And the thickness I gave this was missing profiles. Fantastic. Let's try that. This isn't working. Missing profiles. Don't be missing profiles. What's going on? What is this changed? Symmetric? Is it really? Divided by 2 plus 1. Clunk. Okay, fine. That is it. Hope this isn't going to screw things up down the line. And we can measure that, and that's 7.7 millimeters. So again, a bit more round than the other numbers, but that is effectively, if you think of it as a little chunk of metal, this is what we're going to carve to make our iPhone. Really, really, really simple. 9 times out of 10 I'll start off with something like a rectangle. And if, certainly for any hard surfaces, if I'm doing something a bit more free-flowing, we might do something here with the freeform sort of tool. But for this particular thing, because it's geometrically very rigid, we're just going to stick with it. Okay, so next step. What did I do? What's this exciting? Okay, so next step is to create the profiling for the corners. Now, the profiling is done. It's not as simple as doing a radius. The corners are profiled, as you can see here. This is a G2 continuation curve, but the best way to do it is to basically these dimensions straight from the data sheet, telling you the exact profile of the curve, and that's what I've created here, just using the spline tool, and just made sure that the handles were at tangents to each other. So it's nice and sort of simple. So basically just clicking, click, 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 and then just dimension up as per the data sheet, which you can see are here. Now, I will make this model absolutely available for anyone who wants to have a tinker with it. I'm not going to hide away from it, rather than me providing you with a drawing to do. It's probably easier if you just have a bash yourself. Okay. The only other thing that I've done with this is I created one profile here, and then I've created some symmetry lines, and I've used the symmetry constraint to mirror and oh, it wasn't symmetry, it was mirror, that's right. So it's a mirror constraint to mirror this geometry. It's not even a constraint, it's a mirror feature, beg your pardon. Like I said, this is a bit rambly. So you mirror that, you know, vertically and horizontally, and then you can end up with everything's the same, everything's constrained the same. So if I make any dimensional changes here, it's reflected on all four corners to save you some time. Okay, so there's your sketch. Next step is we want to cut away the profile, which is exactly what's happened here. So with cut, it works in exactly the same way as it's an extrude, but instead of adding, it takes away, and that's exactly what's happened here. So again, lazily, I have just whacked them as an arbitrary amount of 15mm because I know it's not going to get any wider than that. Just, you know, there you go. So okay, that I think you know, it's starting to look a bit more iPhone-y. You know, it's still very, very square. It's still missing lots of nice little features, but basically, you know, it's there. Okay, next step. Okay, now this was actually a little bit trickier than it's going to look like it was. This was a little bit of a trick, and what I've done here is created this sketch to carve out the side profiling radius, which, as you can see, all the dimensions here. And the way I've done that is pretty much the same as I did with the other profiles that I created, apart from I've done it, you know, through this geometry here. And to make this work properly, I had to then add these extra rectangles around to remove any extra material that might kind of sneak through. Like I say, you know, this took a little bit of tinkering to get this right, to make Fusion sort of happy with it, and that's not Fusion's fault at all. It's just because, you know, the way the profile exists is a little bit weird. So I got it going. So anyway, so after that, there's that profile. What have we got? Yes, actually, you know, this is all coming back to me now. Okay, so I created the profile, brilliant, and I haven't chopped anything off yet because there was another little issue. Now, because of the way I created these profiles, they're not actually a proper continuation curve, which meant that Fusion kind of saw each part as its own individual segment, and it would not really sweep nicely round and you know, trim it as I wanted to. So it's not perfect, but the workaround for that I found was to actually add a fillet on where these joins are and do it as a continuation curve, and a continuation curve just basically means that it's got perfect transition between each surface. Again, fairly arbitrary, 8mm, just to smooth that off. Okay, and then the next step was to create the sketch for the sweep profile. And the sweep profile, again, I created on which plane? So just the origin plane. And I've projected this face onto here. And what that does is that now gives me a nice path for me to run a sweep around, and you'll see that in a second. Okay, next step would be to do a sweep. So what we're going to do is do that sweep. Ta-da! Okay, so the sweep has now swept all the way around and chopped this edge around to make it all round and smooth. So if I turn off these sketch profiles, you'll see all the way around. That is now looking very, very, very iPhone-y indeed. Now, obviously, it's missing a screen and it's missing a camera and buttons and things, but we'll come to those in a second. Now, the profile here, you can sort of see, if I zoom in, you can see that there is actually this little nip here, and that is that's part of the design. That is effectively where this is the screen and this is the main body of the chassis. And when I did the sweep, as part of this profile, I made sure I had this little nip here, and I just basically selected this, and then that swept around and cut that out nicely for me. feel free to slow this video down or speed it up, but you know, I'm just gonna go through. This is exactly the workflow that I went through, and I think the first time I designed this, it probably took me 2 hours from kind of having to think about, you know, how I was going to create things. Anyway, okay, so there's that. Brilliant. iPhone, fantastic. Right, next step. What have we got? I've created a construction plane for reasons. And this construction plane will be for a thing we don't know about yet. So let's check out what's going on. Okay, next. I have done a split body. Excellent. Right, so what I've done is, again, from the data sheet, you actually get to see where the glass of the phone comes. So this is like the main chassis of the screen, and then this is the main kind of glass and touch screen and things like that. And what I've done with Fusion is I've just created 2 bodies. So I've split them into 2 pieces, and using the split body feature. So if you double click into that, what I've done is I've created the split body by selecting the plane that I created, an offset plane to the correct dimensions, and then the splitting tool, and this is the body to split, and then it just splits them into 2 across that plane. And there you have it. Now I have a back and I have a top piece of glass. It just makes things easier to work with down the line if you sort of have everything kind of in separates, especially when it comes to rendering anyway. You know, if I was doing this really properly, I would probably have this as a few separate components and things. But for what I want it for, this is absolutely fine. Okay, next step. Radiusing. Right. So what I've done, and again, this is just a teeny little radius, and this is to accentuate the. As you can see, it's 0.02, so 20 micron radius. And it's literally just to accentuate this gap here. That is a bit of artistic license on my part. I'm pretty sure that Apple don't do that, but it just means that it mocks real life. You know, in the virtual world, you'll have nothing but perfectly sharp straight edges, but in the real world, you'll have some rounding, and that's what that is. And that just, again, it just makes that screen just stand out just ever so slightly. But again, that's entirely optional, but that's what I did anyway. Okay, and then another fillet. Where have we added this one? Because this is exciting. It's been a while since I've done this. Okay, and I just added another one here. So this one, again, fairly arbitrary. I kind of eyeballed this one, and it's a 50 micron radius versus a 20 micron radius. Again, just to accentuate where those 2 join together. Okay, next. I've created another fantastic construction plane. Let me just turn these construction planes on so they're pretty cool. And what I'm going to do here is I'm going to separate the back glass from the main chassis, I think. Let's find out. Here we go. Aha, yes, I remember now. Okay, and we can start seeing some materials are starting to pop on now. And this is, so we've got the back, we've got top glass, and then we've got the chassis in the middle there. Done in exactly the same way, just by using a construction plane, an offset construction plane, which is created really easily. I'll just show you quickly. Construct, this is an offset plane. You click on the plane you want to offset, and then you just drag or put accurate 1.5 in, and then that is correct. We don't actually need that, so I'm going to make that go away. Okay, next. More radiusing, and this again is an aesthetic thing, just to separate up the back glass from the main chassis, and that is more to do with how it's going to look when it's rendered more than how it's going to be in the real world. But you know, it's a tiny radius, so it's still considered to be pretty accurate. Okay, another construction plane. I think we're going to split something else here. This is very exciting. Let's find out what it's going to be. Did anyone notice what split? Let's find out. Right, here we go. What have I split? That's the split. Let's just go into this. Oh, I see. Okay, yeah, I got it. Okay, cool. Bear with me. Okay, fine. So just another split, and this is just following the data sheet. So on the iPhone 10, it does have a variety of parts that are obviously bolted, glued, and magnetized together, and this is just another one of those pieces there. Okay, another construction plane. Let's turn this one on, see where this is going to go. Okay, right, Now, this is going to be all about, just turn these other ones off. This is like side buttons and other bits and bobs. So we're going to actually just start carving out some features and make this, actually have things. Okay, so created a sketch, and we've created the sketch on this construction plane. So let's just dig into this sketch here. Okay, once again, all of these dimensions spectacularly not inaccurate, that's not fair, but they're not very round, and it's driving my OCD completely barking mad. But these are what the dimensions are. They are dimensionally correct in theory, of course. There's always going to be tolerance in the real world, but dimensionally correct in the virtual world as per the data sheet. And it's effectively what I'm going to do is I'm going to carve out a space for the volume buttons up and down and the silence button, and these are where they sit. Okay, so let's just stop that. And again, simple extrude, an extrude cut. Now, this is a bit of an arbitrary, distance I've done here, and this is just literally just so I've got somewhere I can actually create a button. The information that gets given to you is an external dimensions only. You don't get any of the fancy internal workings of the chassis or anything like that. Okay, so there we go. Ta-da! Let's turn off that sketch, and then what have we got? Right, we're going to make some rounds. Round, brilliant. Okay, and again, as per the data sheet, rounded to, let's find out, it's exciting. Wow, maths, look at that. So that. not very round numbers, but that's fine. And then again, we're going to do some rounds for the sleep wake button. Of course, it's not completely round this time. Okay, message, brilliant. Okay, wait for that to go away. Go away, message. I'm busy doing things. Okay, fantastic. Right, next, what are we going to do? More sketches. Oh, this is fantastic. Right, sketch, turn that sketch on. What's he going to do? Okay, make buttons. So what I've done for this, could consider it to be lazy, because again you don't really get the dimensions for the buttons and things like that. Again, I didn't have an iPhone 10 at the time I designed this. So what I've done is an offset feature on a projection by 0.1, just to give me something to extrude out. And if you're looking for that, the shortcut is O, but if you're looking in here, it's offset. And what it does is it allows you to grab some geometry and literally offset it in or out pretty much as far as you like until it says you're going too small. So fantastic. I'm going to cancel out of that. Stop. Right. Next, we're going to extrude these bad boys out. That is correct. Okay, yes, it was the sketch that was throwing me there. That looked really weird. Okay, cool. So there we go. There they are. Of course, they are not finished yet, but they are. There are some buttons even. And next thing is I've actually used the sketch from earlier that we created to smooth off these buttons, so they're actually following exactly the same curve as that, just so it looks a bit more pretty. And again, I just used an offset on the sketch for that one. Artistic license, but you know what? It kind of makes them look a bit better and a bit more proper. Okay, and what did I do with that? It literally was just an extrude. Thump. Minus 73mm, because why not? Okay, and then the next step, we're going to add in some chamfers, or chamfers, depending on what side of the pond you're from. I'm the British, so they're chamfers. And again, it's just a little chamfer, and it's just to pick up any little highlights. It's a 0.1 chamfer, which in the real world there would be some kind of chamfer there just to take away any sharp edges on any metalwork. I've added them in because it's going to give a nice little highlight on any of this, transitioning metalwork and things like that. Okay, next, more sketch goodness. Right, here we go. So what we got? We're going to make a sleep-wake button. Now, there were no dimensions for this one. Again, this is a bit of eyeballing, but we've just kind of made it that big, and that is okay. It's in a little bit. It's just slightly off-center. It's 1mm big. A bit of guesswork, but you know what? It's close enough for rock and roll, as they say. Next, we extruded it out. Ta-da! Right, okay, so there we go. An extrude, and that's that. Right, and then what are we going to do with that? Round it. Oh, it's a nice little fillet. I don't know what the value is, but you can dig into the model and see for yourself. And then we've done an extrude, and this one is a little bit of a fudge because it's just following that same curve, and of course in the real world that's going to be just a flat and it's not going to be curved, but for this it is absolutely fine. I'm fine with that. And then added exactly the same 0.1 chamfer on there just to sort of make it look a little nicer and have, you know, a little bit of a transition, a little bit of a highlight and that sort of thing. Next, I've done another chamfer somewhere. Now we just need to discover where I did it. Aha, look at these. Brilliant. It's exactly the same reason. Just another, this was even tinier. This is a 50 micron chamfer again, just to sort of take away that sharp edge. And allows, if we were to do any close-up renderings of this part, you'd actually be able to see there is a nice kind of highlight, you know, around that. It's not going to be sharp. And I think one of the things when it does come to rendering is you have to add in the real world. You have to add in imperfections. If you don't, it never looks right, ever. And this is just from pure experience on my part. Okay, so I've created a sketch. Well, this is exciting. So what we're going to do here is we're creating the screen profile with the very divisive notch in the top. And to be honest, I've had an iPhone 10 for about a week now, and I don't even notice it anymore. So I think it was a lot of fuss over nothing. But then whatever, I'm a fanboy. So okay, so what I've done here is effectively just, you know, I've done an offset profile around here, and then I've created this with just adding. This started off as just a rectangle, and then I've just added some fillets just to round it off, and you'll see why in a minute. And again, this is not absolutely perfect, but it's probably within sort of 0.5 millimeter or even 1/4 millimeter. So for me, it's about right. Okay, we'll stop sketch. Next, we are going to split a face. So let me turn this sketch off. So now, if you go into, this is a different thing. So it's actually not going to split it into separate bodies. The body will remain, but what it does is effectively etch. Well, it doesn't etch, it splits the face. So you end up with two individual faces. And the reason I've done that is because I want the screen, I want to be able to put some other color on there, another decal or something like that. Whereas the notch up here, I want that to be, you know, the same sort of colour as around it. But you'll see. Just bear with me. Here we go. Okay. Next, I have created another fantastic work plane somewhere. Okay. I know what this is going to be for, and I don't know whether you do, but I do. This is going to be for speaker holes and for lightning ports and all that sort of gubbins. So let's move swiftly on to the next step. Let's turn on the sketch and see what's going on. Oh, I've drawn a thing for some reason. That's fantastic. What is that? Let's dig in and see. Ah, now what I'm doing here is I've dimensioned a hole. You can't see the hole yet because I've not created the hole feature, but what I've done is just taken a point. So this is a point. Point creates a sketch point. They're very good at this. And you bung that on there, and then I've dimensioned it up. You know, and I mean, I dimensioned it. You didn't have to do that. I mean, it is literally a dead center. It's on that line, but I've dimensioned it up just to be absolutely sure everything's hunky dory, and that is exactly where that first hole's center point is. Okay, so stop that sketch. Okay, here is a thing. So we've created that sketch. We've come back out of that sketch, and now we are going to create a hole. And the hole is for the speakers / microphone because they're kind of split half and half because they've now got stereo out the bottom, and then when you got it the other way around you get stereo out the earpiece as well. It's very, very good quality sound. I'm going to move my microphone. I'm going to edit this out. No, I probably won't because it wasn't too noisy. Okay, fine. So there we are. We have made a thing. Now the next thing we want to do is actually add many different holes, and the best thing to do for that is to do a pattern, which is what we've done here. And the pattern feature is I've literally taken that and I have patterned it a nice round 11.28 millimeters for the dimensions that Apple require, because Apple. And that's 6 of those across. So there you go. That's the line I've picked. The dimension, the direction even, and ta-da, brilliant. Next, what have we added here? The world's tiniest chamfer. Look how tiny that is, because that was the biggest that Fusion would let me do it, and that was because of this curve, and it's not Fusion's fault, because those are at tangents with each other, and there was too many intersections and vertexes and all sorts of things for it not to work. Not Fusion's fault, it's my fault, but, you know, still there nonetheless. Next. Oh, we've done another sketch. Here we go. Let's turn that sketch on, see what's going on. And this is another hole. So this point here, pop, and it's dimensioned within the thing. The thing, the technical term for a sketch. Look it up, it's in the dictionary. And then we move on, and there we are, there's a lovely hole. Check out the hole. Exactly the same size hole as the ones over here, and we're going to do exactly the same as we did over there, and we're going to add a nice, oh god, we've gone right to the end. Ugh. Oh, can I cancel this? Can I? Oh no, it's alright, don't panic. Is it still upgrade? Okay, brilliant. Now it's gone all the way to the end. Yes, I didn't want you to do any of that. Fantastic. Right. Brilliant. Okay, ignore that happened. Shall I edit it? No, we'll leave it there because it's warts and all. Excellent. Right. Anyway, so this is your timeline for anyone who doesn't really know about Fusion. Check it out. Anyway, so next. Don't hit that one because it takes you right to the end. What you want to do now is this one. Next step. And the next step is exactly this. So we've added in another bunch. 6 in total, so another 5 holes, and that's going to sit perfectly on a tangent here as well. So then you've got these points here, point there. So trying to do a nice chamfer on that one is also, I was going to swear, it's going to be difficult. Okay, right. So we're going to do another sketch here. Let's turn that bad boy on and see what's going on. Aha! Now, guess what this is going to be? Yes, you guessed correct. This is obviously the lightning port, which I have dimensioned to be 3mm, but oddly for me, I don't think I've actually dimensioned it to actually be anywhere else, which is weird. Bad practice on my part, I am sorry, but this is warts and all, yeah. Right, next. Extrude. So literally taken that and we've just chopped in, and again, fairly arbitrary because this is more about, you know, how it's going to look in its placement. And the next step will be to radius that, which is done there, and that now looks jolly splendid indeed, just like a lightning port, just a little bigger without the connector and whatnot in there. Next step, another one of my favourites is a teeny tiny little chamfer. What size do we do? 0.1, good size. Just to give it a little bit of a, you know, a bit of a highlight around there when we come to render the thing later down the line. Another sketch. What do we do? Ah, right. So this is going to be to kind of create the inside of the connector, and which we did that simply with an extrude. So if we just turn that off, you can see here I've over extruded because what we want to do is actually, again, using that same profile we created earlier on, is just to carve that part off there. He says that he's about to do it completely differently. Haha, I am doing it differently because we're on a flat surface, we don't need to sweep it, so it was actually much more straightforward. I created a sketch on the origin in probably the YZ plane, or YZ, depending on what side of the pond. I'm British, so it's Z. And then just created an extrusion for that one. So, and that then chops that back, and that is now perfectly in line. Again, bit of artistic license with that one, but you know what? It looks pretty good. Next, another lovely chamfer. Now, this chamfer looks like it might be special. Let's have a look. Aha! Now, this isn't just a normal chamfer. This is a 2-direction chamfer, and what this means is it doesn't have to be 45 degrees. I can make it anything I like. So what I've got is I've got it 0.85 going inwards, 0.25 going outwards, and what it allows you to do is create a very shallow looking chamfer there. This is all from eyeballing, so don't quote me on that chamfer, but it kind of looked nice. Right, so next we've created another sketch, and this sketch is probably for holes again. Yes, so these 2 points here were created on the sketch, and these are going to be for the screws, that the only visible screws on the entire phone. So let's go through to here. And I've just created 2 fairly arbitrary holes. Again, the depths are arbitrary because you can have a screw in there in a minute. See that in a sec. What have I done now? I've created another sketch. Let's look at these sketches. All about the sketches. Always about the sketches. Okay. And the sketch for this is created to create a counterbore for the holes, for the screw heads to sort of sit into. Because this isn't a planar face, I wasn't actually able to create a counterbored hole. Maybe you can. I couldn't work it out. I'm sure the whizzes from Autodesk would be shouting at their computers right now telling me I've done it wrong, but this is how I did it and it worked. Right, so what I did is then just created an extrude and just extrude it in, and it means that I then get a planar face for the screw to sit on, and I get a recess for the screw head to fit into. Okie dokie, what does this thing do? It's a base feature. Aha! Right, so what have I done? I've done a screw. Have I done a screw? Where's it gone? I've brought it in somewhere. Highlighting it. Oh, of course. Now, this is a screw that I bought in from the fantastic insert McMaster car part component. It says there, sorry. And I literally searched for the smallest socket head screw that I could find because they didn't have anything that was teeny tiny. And then I cheated a little bit. Not really cheaty, but a little bit. And I use the scale tool to just scale it down to a ballpark size for what I want, because it is a very tiny little screw. Where is scale? No, that's sketch. Where are you? Scale, modifier, scale. And you literally click on that and drag it until it's about the right size, or you can type in a specific kind of coordinate or something like that. Anyway, that. Brilliant. So now we have a screw, and it's kind of sat in between there. Not ideal. Next, there it is. I've moved it. That was me capturing the move history, and I've shoved it. And as you can see, it's a teeny tiny little screw. Very, very pretty. Torx head, probably. Actually got a thread, everything. I mean, they're highly... the screws are insanely detailed when they come from McMaster Car, which is good and bad, but, you know, for this, it's fine. So that's great. So next step, I then just plonk that in place. And just done a rigid joint on that, because could I do a rigid joint? Apparently I can. Well, there you go, and it's in place. So I think I did the rigid joint just to hold it in place, and then the next step will be just to copy and paste. Oh, it's so hacky, but it's fine. It's fine. It's fine. There we go. And then we're gonna move that for some reason. I don't know why. And I know I moved that so I could then do a rigid constraint, and now that is now in place and beautiful, as you can see. Let me just turn off this sketch. So, I mean, that's starting to look pretty damn real, isn't it? I mean, you've got screws in there, you've got holes, you've got a lightning port connector. Now, I haven't put in all the things in there because it's going to be shadowed anyway. But anyway, so let's move on. So it looks like I'm creating another thing. Let me just turn this on. Aha! Now, this is going to be for the SIM card slot, if I'm much mistaken, which I am often, but not today. Oh. No, this is a sleep wake button. Okay, fine, whatever. It's on the same plane, so exciting. So, again, dimensions here. Let's just dig into the sketch and see what the crack is. Anyone? There we go. Lovely round dimensions once again. So we've got 41.39 millimeters from the top to the center of the sleep wake button, and it's 8.54 millimeters from the center to the edge. Brilliant. Thank you very much for the accuracy there. Next, we are going to extrude that in and at about the same amount as I did last time. Fairly arbitrary. They're probably not even exactly the same, but, you know, just in enough to do a thing. And then round those off. Round. Beautiful, right? And what radius do we do those? Do I calculate it? Maths, yes. Anyway, sorry. Good. I'm impressing myself because it's been a good month or two since I've had a look at this model, so it's doing well. Next, my favourite, guess what it is? It's a 0.1 chamfer. Once again, they're purely for aesthetic reasons, but to simulate any sharp edges that have been taken off in production, which they will have been, otherwise you'll be cutting yourself, and Apple won't like that. Let's turn on this sketch. And again, this is just going to be me creating a button in exactly the same way as I did last time. I've created a sketch. We've used the offset tool to offset in the projection of that profile by 0.1, just to give me something to extrude out. So next, ta-da! There's a button. It's doing a thing. Brilliant. But as you can see, it's far too long. So guess what we're going to do? I don't know actually. Let's find out together. This is going to be very exciting. Oh, look at me go. I've created a thing. Rather than doing a sweep, I've literally just created a sketch on the mid plane there, and I've offset it, and I'm going to extrude that out to chop off the excess of the button. Don't judge me. Here we go. Dom. There he goes. Clean and tidy. Oh, and one more thing. Chamfer. Chamfer. Britain. Right. Good. next, a sketch. What could it be? Ah, haha, Sims. Right, so this is where the Sim's going to end up being, right? This is a little bit more different, I think, than we're used to doing. So we're going to do another one, and we just extrude that in. Very exciting. We know how to do that. You know how to do. Extrudes are easy. Extrudes are the basis of pretty much every 3D model I ever do, and I'm pretty much sure most people's as well. Okay, and what have I done? Oh, filleted, fillets, roundy, roundy, roundy. Brilliant. So that's round, and probably what's next? A sketch, right? What's the sketch? Same thing. So we're going in here, and this is going to be 0.1 offset from the projection, and I have extruded that out. Very exciting. And then I'm going to reuse the previous sketch that I made, which was sketch number, not that one, sketch 19. Because the great thing about Fusion is you can reuse, previous sketches as long as they appear, in the previous part of your timeline. You can use them as much as you like, which is fab. So I've just used that slightly differently because I've actually wanted to chop. So this is completely flush rather than poking out because it's the sim holder. Cool. Magic. Right, next. What have we done? We made a sketch. We have a sketch. What does this sketch do? I've made a sketch there, projected it there. Right, okay, and this will be because I'm about to make a hole. Here I go. And the hole, I think, again, this isn't 100% accurate as placement, but you know what? Eyeballing it, it's about right. And the hole sizing is about right, and the chamfer is, because I like them, whatever. Sue me. So that's that. Beautiful. Right, next. We've made another sketch. Let me just turn off these construction planes because they're ugly. Turn this on. What we got? Aha! What's this? This looks very much to me like it's going to be a camera. It is, right? And again, fabulous dimensions here. You've got 24.13, you've got a radius of 5.63. Fantastic. Anyway, and all the dimensions are perfectly awkward, so enjoy those. Okay, next step is a simple extrude of that. Now, did I do something different? I have done an extrude, but it's a new body, okay? So it's not joined to this, and the reason I've done that is purely down to when it comes to rendering, it's going to make life a lot easier if the camera is just a separate bit, and you'll see that a bit later. If you're still watching this video, which you probably aren't, hey, whatever, I'm going to chop it up, so it's all good. Right, brilliant. Back to it. So, chamfer, of course, but this is, not just aesthetic. This is actually on the thing. So that's there. 1/4 millimeter chamfer because it looks pretty. I've done another sketch, and this sketch is to do with the earpiece. Yes, look at that. Dimensioned, probably fairly eyeballed. And I have, what have I done? I have extruded that one in, and I've done a round. There you go, and there's an earpiece. That's good enough for what we want it for. Oh, lovely little, it's not a chamfer this time, a nice radius. How small? Fillet, 0.1. Well, 0.1, it's the golden number, isn't it? Okay, now we're creating another sketch, which has gone somewhere. Look at all these lovely sketches. Oh, look at this, eh? Look at it. Oh, another message. God, I'm so popular. Look at that. Apple. Yeah. Anyway, do you want to see how I created it? Because it's like super. It's fine. Right. So what I created with this was, where's the thing? I had a thing. How did I make this? Did I not have a decal canvas? How did I do it? I'm just a genius. No, I must have. Oh, do you know what? Do you know? I think I was really lame, and this was actually no. Something's gone funny here. Right, scratch that. Right, so awesome. Now this was created using delicious splines, as you can see here. The apple shape. These were arcs. And that was an arc. This is not 100% accurate. This is fairly eyeballed, but this would have been done from a reference image, and for some reason it's not there. I don't know why. Anywho, Next. Oh, hang on. Oh, right, so I'm kind of a little bit topsy-turvy here. Let me turn the canvas on. Aha, there it is. There's a reference image. Now, I don't know why my reference image in the timeline is before the sketch I created of it, but there you go. There it is. This explains a little bit more to me. Yeah, Fusion people will be able to explain as per why, but there it is. And I literally, it's just a... I think it was just a PNG I got off the interwebs, and I've just drawn around it. I mean, you know, real technical, with some splines. And then I have extruded that out some teensy amount. Hang on, let's turn off this canvas. Canvas is erased, by the way. It gets you get to put in images and whatnot, so it's awesome. Okay, and I've extruded this out in, beg pardon, 0.1. So there we go. There we got, like, you know, so we've actually got an apple, you know, etched into the back of the thing, which, and then just because, you know, it's not going to be completely flat, I have created an extrusion of that sketch, and it's just in a teensy tiny little bit, just to, you know, give you something, and it's extruded out 0.1, and that just gives you, you know, a kind of an inlay feel. Excitement. Oh, well, I've done another chamfer as well, of course, just to make that stand out. And I'll tell you, for one thing, there is not a cat in hell's chance Apple would do that, but screw it. This is mine. This is my design, so I'm doing what I like. Okay, more sketches. iPhone. You know, I don't think it's the right font, but close enough for rock and roll, no? Here we go. Let's double click into that. What is it? iPhone Arial. Yeah, I'm fairly sure they don't use Arial, but you know what? I bloody well do. And it's dimension, so that is exactly where it's going to be. The Apple logo, on the other hand, is a bit eyeballed, so you'll have to just bear with that. Right, so there we go. What am I going to do with this? I'm going to step, and I'm going to extrude. Oh, look at that. It's so pretty. And I've got, right, so I've extruded in, again, 0.1, and out again. Just offset. What did I create as new bodies? Ah, they're new bodies. Okay, cool. Different colours. Fabulous. I think. I bet each letter is a new body. Let's explore together, team. Who knows? Do I need to, oh, here, look. I've even labelled them. That's an N. That's an H. God, impress myself. I never label anything. Look at me go. I have terrible word processes. Why are you even watching this video? Anyway, cool. Done. Right, next. What's that? What's this? What does this symbol mean? Well, this is a decal. And this is when we start adding on some pictures. As you can see, that camera looks pretty good. And now I could, if I had the time or inclination, or even had something to properly reference, I could have modelled all of these things. I could have modelled the lenses, I could have modelled the flash, the microphone, everything. But on the other hand, you can go on the internet, get a picture of the camera, and then you can literally place that image on that face. And it looks good enough. Brilliant. Next, another one. What's it going to be? The other camera. So this is the little forward-facing camera, little bink. And these are the only things you can see. Now, there are other sensors and bits and bobs underneath this little dot. And, yeah, well, you know, the face recognition, the dot projector, all that sort of business. You can't see them. They're hidden away because they're all sort of infrared, so you can't really see them, even with shine the lights. And the only things you can see are the earpiece and the camera. Now I've created a sketch. Let's find out together what that sketch does. It's all very exciting. I've created a sketch that does something. Let's find out what I'm trying to do. I have a feeling I'm splitting a face here. Let's check. Diggy diggy. Right, so 0.1. I've done a thing. Right, well let's work out. There's going to be a reason for doing this. Here we go. Split. Ah, right, check that bad boy out. Okay, so what I'm doing here, this is to simulate where the chassis splits and accommodates for the aerial. God, you know, all these little details. So I've just used, again, it was just literally the split face tool, and created line here and each face now. So these are just individual things, and what it means is we can add different colours to these things as we go along. Created another sketch, it seems. Let's find out what that sketch does. this is another one of those things. So this is all going to be about creating the split faces, so the aerial configuration can be seen. Not 100% accurate, but aesthetically, you can see it. It's pretty good. Okay, what have I done now? A decal. Oh, now you see this is just so super lazy. I have done a decal of that texture there, and to be honest, more messages. God, so popular. I could have modelled that, but why? It's such a tiny little thing, and it's just a nice little aesthetic touch. God, look at that! And that is the last decal, and that is the screen. So pretty. Look how colourful that screen is. Tuesday, September the 12th, and that is pulled straight from one of their sample images. I could probably update that, but I ain't gonna. Right, what are we doing now? I am making something into a component, because that's a good practice, probably. Right, and what the components, I'm going to do this a few times, it looks like. Right, they're going to scroll down. Oh, there's still tons to go. Stick with me. Okay, here we go. What are we doing? Right, here we go. Brilliant. Back. I've made a back, and I've labelled it as such. So now I have a back, and that is a component, which means I can move this around, and I can constrain it and do all sorts of other fun things. This is, what's this? Oh, right, okay. Oh, right, I wonder, actually. So a lot of this stuff that you've got is actually to do with a case that I have designed, which, to be honest, we don't need to cover today. So, for all intents and purposes, I would say that that is done. Right. Here we have our iPhone, and in Fusion360's modelling environment, it doesn't look that bad, in my personal opinion, considering it is an orthographic view, and you're not getting any sort of ray tracing or anything fancy. Sorry about camp. Okay, so what we're going to do is this. Click on model, and we're going to go into the rendering environment, and this is where cool stuff happens. Now, as you can see straight away, the one thing you'll probably notice going into the rendering environment is, we've got some other cool stuff set up. So now this is just hardware rendering, and what hardware rendering? Now this is hardware rendering, and what hardware rendering means is the graphics card is doing all the work, and it's pretty much surmising, what the light's doing. It's got a pretty good idea of what things are happening, but it's not 100% accurate. So, how do we make it look more real? Well, number one, ray tracing, or as they call it in here, in-canvas rendering. So if you just click on this, I don't know, what is it? It's a ball with a triangle for reasons. I'm sure that means something if someone would like to tell me what that means. And then, as you can see, it's going to slowly create the image. And what's happening here is it's actually the CPU is calculating all the light photons bouncing around this virtual world and how it interacts with the materials that you've applied to your geometry. And as you can see, as it gets clearer and clearer, the more calculations it does, the more passes it does, the more iterations, this number here, iterations, you can see with every iteration it becomes clearer and clearer and clearer and clearer until you end up with something that looks pretty damn real. Okay, so we'll move on to that in a second. So, rendering, one of my favourites. I love rendering, I love making things look real, I just enjoy it. Don't ask me for why, but I do. So my workflow is not quite the same layout as they have here. So if we go through all the buttons, you've got appearance, which is effectively the materials and colours you're going to add to your things. Scene settings, setting up lighting, camera settings and things like that. Decals, which we've already placed, because you can do those in both, but decals are images you place onto faces and bodies. Texture Texture map controls allow you some on-the-fly tweaks and changes to how your materials are wrapped and projected around your geometry. Okay, we don't really care about physical materials in this particular instance because we're only caring really about how it looks more than actually what it does. So let's go appearance, which is always kind of a good place to start, but what I tend to do is kind of flip between appearance and lighting because the two have a very symbiotic relationship and do tend to affect one another. So one set of materials will look good in one scene and will look not so great in another, so you do have to tailor and tweak as you go. Okay, so with this we've got a few materials you can see here, and I'm just going to delete all the unused materials because we don't actually have that many. What's going on here? All hanging off the screen. Okay, here we go. Select objects applied to. So we've got Chrome. And Chrome I've used for basically all of this main chassis here. And what we can do within this, materials. Oh, that was so loud in my ear holes. Kevin Bridges, brilliant. Go away. Go away. There we go. You can make all sorts of changes and tweaks. So this is. I mean, I think I pretty much took a stock Chrome material and didn't really make many changes to it. But now I actually have an iPhone 10. I know that even though this is very, very shiny, it's not perfect. So what we want to do is just increase the roughness. And if you look closely, so click done here as I see if we can get something shiny here. As I increase the roughness, kind of the shininess goes away. And it's exactly what it says. It's instead of being a perfect surface, you're literally just roughing it up just ever so slightly, just to kind of make that look a bit nicer. Other materials, satin, steel, which is a non-standard material I have modified. And this was used for these faces here. Now to apply materials to faces is a little bit different. So if you click face, instead of clicking bodies and components, you can actually select individual portions which we created earlier on, and you can take those materials and drag and plop and put them on. And that's exactly what I've done here. So then, we can make that any colour we want. Bright red and all sorts of stuff like that. It's just yuck. So I've made this like a satin grey because that's what they are. Other materials I have. Look at this one, bright yellow. I know what that's for. That's for the case. Ignore. Next one. This one will be this top part here, this back part here. Now, interesting fact, factoids, and we can actually correct this, is when I first got this model and information stuff like that, I just assumed that the top glass and the back glass are actually the same colour. They are not. The top glass for all of them is the same, and it's this kind of very glossy. I've got this actually as a paint because it actually replicated the glossy glasses very, very closely indeed. But actually the back is not black. They are either space grey or they are a silver. So actually what we can do together as a team is actually work this out. So this is actually a really good starting point. So we just duplicate that. And first of all, let's change the colour. So we're going to make it a bit lighter. I'll click done, and that's that. We're going to plot that on there, and we are going to do the same for that outer part too. We've done its faces. My bad. Right. Control Z is your friend. Control Z, Control Z. Hey, my video. Do I like? Anyway, so we want it on bodies, not faces. Bodies. Plonk. You see? Now that's looking a bit more interesting. Maybe it's a little bit too... It's shiny. We're going to make that a little bit more rough. This material is not really doing it for me, to be honest, but I think we'll get fairly close-ish to the back colour. Now mine is the silver, and it's not far off that. It's a little bit lighter. Let's tweak that up a little bit. And the reflectance, we can have that not particularly reflecty, is it? But you know what? That is pretty damn close. So the top is black and the back is white. Ta-da! We have fixed a thing. Saving that. I'm going to add a new version. Ta-da! Right. Brilliant. Right, back to it. Clonk. Okay, so what other colours we work with? We've got glossy, we've got the chrome. What did I use chrome black for? Let's see. Right, I've used that for the round bit here. Now, that's interesting. I wonder why I did that as chrome. Black chrome, I think I probably did that to make it stand out in the rendering from the other parts. Other parts, there'll be chrome. We've got the screw that is chrome, and this inner part here is also chrome. So, you know, to be honest, a lot of it's a similar sort of colour. And I think the only other part, you know what, this is missing, and let's add it because it should be there, is this fantastic bright orange on that face. But it has a weird texture on it, doesn't it? So what we can do is just whiz in here. I'm just going to scale that down. Maybe up a little bit so it's got a little bit of funk. There we go. Beautiful. Right, so now you've got a thing in there, sort of, you know, kind of like the real one. Right, so there we are. We have a few of our materials put on there. They're basics. And that's it. Right, next step. Scene settings. All looks very terrifying. It is not. Just work through it step by step. Just basically start from the top. And I find it's often really, really easy just to, you know, just have a flick through. You know, I never know really which is going to be the perfect thing. I have some idea, of course, but have a tweak and see what happens. So let's see what environment libraries. I've got the photo booth library up, and if I just click on a few of these, you'll see how each one makes it look different. So it's the photo booth, we've done that one, rim highlights, and these are just different lighting schemes, and this is all IBL, image-based lighting, which effectively is just a big image around the picture, around your geometry, providing all the reflections and the light. So as you can see, you know, they're all slightly different, doing different things. That makes that look kind of nice and shiny. So let's leave on that one. Let's see if we can't make this look funky. Okay, so we are now in, oh, what do we select? Warm light. Yeah, warm light. Cool. And that's got that nice kind of reflection on the top. So we'll see if we can utilize that. Now, I have got the ground plane on, which is effectively just where the back of the thing sits, and I've turned on reflections. You can turn the reflections on and off. They're kind of nice. I like having reflections on, especially if you have a black background, and then you can play with this as if you were on a you know, a rough piece of glass or something like that. So that looks kind of nice. Beautiful. Okay, now next step. Now this is kind of it. This is important, I think. Is when you're creating your camera. Now, number one, you obviously want it in perspective because, you know, no camera is really going to have orthographic faces unless it's, I don't know, zoomed in like 200mm lens or something like that, zoomed in on something. The key thing for me, and again this is just because I've been rendering stuff for a long time, is always make sure that your focal length is a real camera focal length. You know, 55, 90, 36, 28, you know, that sort of thing. Just because it makes handling the imagery much easier. Because, I mean, you can tweak every value in between. Ooh, it goes up and down. Blah, blah, blah. Weird, right? Whereas if you stick with proper values, it makes life a bit easier and actually makes things look more real as if they have been photographed, because, you know, you can't get a 46mm lens. The exposure is generally set up by the environment, but again, you can tweak it. So the higher you go, actually, the more you go up, the lower the number gets, and the higher the exposure goes, and then back down, the lower it goes. I mean, it was set somewhere. Control Z. Oh no, it's gone. 8.9. Close enough for rock and roll. Can anyone remember what it was? Answers on a postcard. Right. The next thing is depth of field. Now, depth of field effects are brilliant. They will make everything feel much more real because they simulate the depth of field that you would get from a camera lens if it was zoomed in on, you know, something close up, or if you had something, you know, in your close field of view, and then you had something very far away in the far view, that would be blurred. What you have in the foreground would be in focus, and it makes things a lot more real. Now you're saying, well, you know, I can't really see any depth of field on this, and you would be absolutely correct. And the reason you can't see anything is because depth of field effects are a ray tracing only effect, not a hardware rendered one. I've seen some hardware rendered depth of field effects, and they're not brilliant. They're okay. They're fine. They're fine. You can tell they're not right, but it's good. And aspect ratio, this, I mean, is up to you. I mean, you can have it as just your screen. You can have it as, you know, Instagram friendly 1:1 squares, 4:3 widescreen, whatever it is you like. For this, you know, we're just going to leave it as the standard aspect ratio, and that's fine. Okay, so now we've got some scene settings set up, we've changed things around, we've moved the model about. That's kind of neat. Let's zoom in a little bit and let's hit the in-canvas render and see what happens. Now, as this ray traces, you'll notice this little green dot here, and what this green dot is, it's the center of focus of your depth of field effect. So effectively where your camera's focal point is looking. So everything kind of to this side and everything to that side is going to be blurry. And as the, you know, and effectively the more iterations it does, the more accurate the blur gets and the more real things will look. And you can see actually this is really, really nice. This highlight on the corner here, this is nice. You've still got the separation of the metalwork from the top. You've got the separation of the top screen from the separation of the main chassis as well, and everything's looking really, 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 really nice there actually. So you can let that render out. Take your time, you know, the computer do its work, or you can do this. Click render. Well, haven't we just done a render? Yes, we have. We were doing it locally. But now you can render, you can still do it locally if you want to type your machine, or you can utilize Autodesk's fantastic A360 rendering system, which will render on their servers in lightning speed and then email, well, they won't email you, they'll just, download the imagery when it's ready. Doesn't tie up your machine, and if you're using an enthusiast license like I do on this particular one, you have unlimited use. They do limit, you know, how many credits you can use in one go, which is fair dues. But to be honest, I've never gone over the 16 really for anything I've done. And then you can click render and you'll download the absolutely perfect iteration of the rendering. It's absolutely brilliant. So let's have a look, see what else we can do with this. So we've got some other points here. So we might want to just say, do you know what? I'm going to change the center of focus. I want the center of focus to be this padlock just here. And that is where the camera is going to focus now. What we're going to do is we're going to do it as an empty canvas so you can sort of see how it works. And as it goes, and as it's ray tracing, you can see my center point, which I'm just going to hide that. Still there, it's still clicked in, but I've just hidden it. You can see that with every iteration it gets more and more real. More and more real. We're up close, we've got some really, really nice blurry highlights just here. Everything's looking really, really nice. Maybe a little bit shiny, but you know, we can tweak that. And now the cool thing is we can actually tweak that on the fly while it's ray tracing. So this is just my sort of toing and throwing, and just, you know, you get really, really sort of tweaky. So now the roughness is 1.64, nice apple round number there. So let's try changing this to 0.2. And then every time you make a change, it has to start again from the beginning, ray tracing, because it has to recalculate all those photons bouncing around, all the materials, what's reflecting, what's not reflecting. And as I can already see, just adding a little bit more of that roughness, that's made that material look a lot more realistic. Wonderful. And honestly, I mean, it's all about trial and error. But as long as you follow the first kind of steps with that, you obviously know what your materials are going to look like. But I think the trick with the materials is to make them not look perfect. There have been many renderings I've seen where people go, wow, black chrome, and they've put black chrome on something, but it's perfect mirrored black chrome. Nothing is perfect in the real world, and I think that's the trick with trying to get something to look real when you're rendering, is to add in the real world imperfections, like roughness, like scratches, like different textures and things like that. And that's kind of really all I do. There's no magic, there's no voodoo. I am literally using the tools that Autodesk have provided, and I am creating these images. That's it. Really straightforward. So what I'll do in the video is I'm going to post the link to this model, so you are welcome to have a tinker and have a play, and have a render and sort of see what you think. Post a link to the Apple dimensions, and I can't post like a direct. I don't think I can post a direct link to the PDF because I think it might be under the developers kind of thingy, and I don't want to sort of get into trouble with anyone on that. So I will put some instructions on how to find them yourself, and then if you find them yourself, then that's down to you. But honestly, if you just follow the steps I've done, all the different things I've done, no special voodoo. Literally, I've just created this model and added some textures, and Fusion 360 is doing it all. Honestly, if you're not using Fusion 360, you really should. It's so easy to use. It's super versatile. Everything is within one environment, so get on it, really. If you have any questions, you can tweet me. I'm on Instagram. You can find me on the Autodesk Gallery as well, where you'll see this model and a few other bits and bobs that I've done. And if you have any questions, do just fire out some questions to me, and I'll do my best to answer them. Of course, there are the experts. I mean, I'm just a user, just some guy. But there are the experts that work for Autodesk, which are all super smart dudes. So they'll be more than happy to answer any of your questions if you do have any. So there you go. That's pretty much it. I'm going to wrap it up right there. If you have any questions, just let me know. Thank you. Hope you've enjoyed it. If you want to subscribe, do. If you don't. I'm really not going to cry. And yeah, we'll go from there, really. If you have any questions, just let me know. Hit me up in the comments below. Thank you very much for anyone who made it to the end.